Hi guys, these are my Christmas lights and I noticed that few of the LEDs are dim. These lights are split into three sections or three circuits. This is section 1, this is section 2 and this is section 3. I'll explain later how to identify these sections. In the third section, you can see that all the LEDs are dim. Here you can compare the yellow and red with section 1, the yellow and red with section 2. I'll walk you through how to identify where the problem is and how to fix it. I hope you'll find this video useful. I'll show you three ways on how to identify the different sections. First is follow the wires. So these two wires will become three wires where the section starts, and then when the three wires end and becomes two wires, so that will be one section. And similarly you can find it out for the next section. The second way is to find the LED which has got these three wires going into it. All the other LEDs will have only two wires. So the first LED with the three wires is the start of the section, and then when you find the next LED with the three wires, that is the end of the section. And again after that you'll have the two wires that go to the next section. The third way is to pull out one of the LEDs and since they're all connected in series, they will all go off. So that will identify the section. So this is the first section and that is the second section there. So if I put it back and then I pull out one from the next section, all of the ones in the next section will go off. So these are the three ways in which you can identify the different sections. Here is a schematic that shows the different sections in the Christmas lights. We have the live and neutral wire coming out of the plug, and then three series circuits connected in parallel. At the first LED, we have the live wire that comes into it, and it continues to the first LED of the next circuit. The neutral wire connects to the last LED of the first circuit, and then it continues to the last LED of the next circuit. This is the series wire and it connects all of the LEDs till the last LED of the first circuit. From the plug we have two wires, and then where the series happens we have three wires, and then between the two circuits again there will be only two wires, the live and neutral, and then this continues again series, there will be three wires. Let's check this in the actual lights. Here are the two wires that come out of the plug. We can also see the fuse within the plug. The live and the neutral wire. The live wire goes to the first LED of this circuit, and it continues to the first LED of the next circuit. From the first LED, we also see the series wire that connects all of the LEDs, and this will go on to the last LED of the circuit. The neutral wire continues all the way to the last LED of the circuit. So here's the neutral wire that comes and to the last LED of the circuit, and then it continues to the last LED of the next circuit. You can also see the series wire terminating at this last LED, and then between this circuit and the next circuit we can see the two wires, the live and the neutral, and this is the first LED of the next circuit, and this pattern continues. We can also see resistors within the circuit. So here I can see that there are 1, 2, 3 and 4 resistors within each circuit. Later on in the video, I'll explain the function of these resistors. This is the diagram of the series parallel circuit showing the 120 volts across live and neutral and the series circuits connected in parallel. There could be any number of these series circuits. In our lights, there are three circuits or sections. The formula for current is voltage divided by resistance. Voltage is constant across these circuits. Resistance in each of these circuits will depend on the number of LEDs and the resistors within each circuit. In our lights, there are 24 LEDs and 4 resistors in each circuit. So the value of resistance is the sum of the resistance of the 24 LEDs and the sum of the resistance of the 4 resistors. Since voltage and resistance is the same across each of these circuits, the current I flowing through these circuits is going to be the same. Hence, all the LEDs should glow with the same brightness. If all the LEDs in the third section are dim, which means that the current flowing through it is less. Since the voltage is the same, this means that the resistance of the 24 LEDs and 4 resistors is more. If the increase in resistance is because of one of the LEDs or the improper contact in one of the LEDs, then that LED would glow differently. In our case, all the LEDs are similarly dim, so most likely the culprit is one of the resistors. There are two ways we can easily find which resistor is defective. The first method is to use a multimeter, and then the second method would be to bypass the resistor and see if the lights glow properly. Let's do both. One of the resistors in section 3 is defective. So I'll be measuring the resistance across these 4 resistors. To start with, let me pick one resistor from the good section and check what the resistance is. Let's start with this one. We'll remove the LEDs adjacent to the resistor and check the resistance across this terminal and this terminal. So we'll touch the multimeter to this terminal on this side, and similarly on this side. I'm measuring the resistance across the good resistor, and it's showing about 0.733 kilo ohms, which is 730 ohms. Let's check the 4 resistors in the bad circuit. I'm pretty sure one of them is going to be a lot more than 730 ohms. This one shows 0.730 kilo ohms, so that's 730 ohms. Let's see the next one. This one is also 730 ohms. Let's see the next one. Okay, this is the wrong one. So this is showing 0.725 mega ohms. So let's check the fourth one just in case. That's 0.37 kilo ohms. So this is good. So then this is the bad one, which we need to change. For the second method, you can use a wire like this to bypass the resistor and check the LED brightness in the bad circuit. The LEDs are still dim, so it must not be this resistor. When bypassing this resistor, all of the LEDs are glowing properly, similar to the other sections. So that means it is just this resistor that's a problem, and all the other resistors are fine. A word of caution for using the second method. If there are only few LEDs in each circuit and say only one resistor, please don't try bypassing that resistor, as that can pass a lot of current through the LEDs and fry them. These are some typical rating of LEDs used in Christmas lights. So 20 to 30 milliamps for current, 2 to 3 voltage drop, and 100 to 150 ohms of resistance. Using the formula to calculate the current passing through the circuit, for a good circuit we get 20 milliamps of current, and if we bypass one of the resistors, the current flowing will be 23 milliamps. So to fix this problem, the best solution will be to replace the resistor with a 720 ohm resistor. But based on the calculation that we did for the current, an acceptable solution can be to replace the resistor with a piece of wire, which is what I've done here. I snipped off the resistor and I soldered a wire, and now all of the LEDs are glowing brightly. Now we don't see any dim LEDs in these Christmas lights. I have wrapped a white insulation tape over the wire that I soldered, so these Christmas lights are as good as new. We can compare the brightness of the LEDs in section 3 versus those in section 1 and in section 2. They appear to have the same brightness. In theory, the section 3 LEDs should glow brighter than the other sections, but it is not that perceptible. I hope you enjoyed this video and it helps you fix your Christmas lights issue. Thank you for watching.